Hi everyone, good morning. So myself, Dr. Vinod PN, Assistant Professor and Head of the Department of Civil Engineering. So now for third semester, this time I am going to handle fluid mechanics. So fluid mechanics is a branch of science which mainly deals with behavior of fluids. So the fluid mechanics is basically from engineering mechanics. So what we have studied in the first year, elements of civil engineering, in that the engineering mechanics has been split into two parts. One is about the solid mechanics and other one is fluid mechanics. So the solid mechanics is nothing but that is going to define in terms of solid properties that we can say the strength of materials on third semester. The same way what you are having in the fluid mechanics, that comprises of the remaining part what you are having the fluid, that fluid word which defines, it's about the liquid and gaseous part. So the word fluid represents which comprise of liquid and gaseous part. So now in fluid mechanics is nothing but we are going to study what exactly the properties of the material. So the same way in civil engineering, the fluid mechanics is mainly defined to study the behavior of the fluid. Means what exactly is it, a rest condition or it is under motion. It is nothing but whether it is moving with or without considering of forces. So the fluid mechanics is further classified into three parts. That is, one is fluid statics, second one is fluid kinematics, and the third one is fluid dynamics. So if you have heard that word, it's about statics, kinematics and dynamics. So now we know the definition for fluid mechanics. Fluid mechanics is a branch of science that mainly deals with behavior of fluids when the fluid is at rest condition or it is under motion. It is nothing but when it is under moving condition with or without considering of forces. So what it has been, the fluid mechanics is further classified into three parts. One is about statics, kinematics, dynamics. So the static is nothing but we know that the static word which defines it is at rest condition. So now the fluid statics, it is the classification of fluid mechanics. The fluid statics that represents the fluid is at rest. So what we are going to study the fluid static, it is a branch of fluid mechanics that mainly deals with behavior of fluids when the fluid is at rest condition. The static word that represents when the property of the fluids is at rest condition. And the second one is fluid kinematics. So kinematics is nothing but the property of the fluid which is under motion. It is nothing but the fluid which is going to move, moving direction. So when it is moving without considering any kinds of forces, we'll say that will be as fluid kinematics. Andre, what you are having that the fluid which is under motion without considering any kinds of forces, we'll say that will be as fluid kinematics. And the next one is about the fluid dynamics. So the same way here what you are having the dynamics, again here the properties of fluids which is under motion condition. It is nothing but it is under moving condition. So when it is moving with considering of forces. So what are all the forces and how which are all the forces will be considered? For example, if the fluid is moving, it may be with the gravitational force, or it may be with the compressive force, or it may be with the viscosity of the force, so or it may be with the compressive force, so which irrotational force or rotational force. So what are all the forces which is going to act and the fluid is under motion. So fluid dynamics is a branch of fluid mechanics which mainly deals with behavior of fluids. So when the fluid is under motion, it is nothing but when the fluid is under moving condition with considering of forces, either it may be pressure force, gravitational force, or it may be compressive force, etc. So these three represents the sub-classification of fluid mechanics. So now I'll enter to the syllabus. So what you are having in now the ideal scheme, the fluid mechanics. So it comprises of 5 modules. That 5 modules is having 10 chapters. The first module is having 2 chapters. The same way each module consists of 2 chapters. So in fluid mechanics, the first module represents, it's about the properties of fluids. It is nothing but we have to study what exactly the fluid and what are all the properties. It is nothing but what we can say the characteristics with respect to SI units. Okay. The next is about pressure and its measurement. So in the fluid mechanics, the first module says that it is all about the introduction about the subject. It is about the properties of fluids. So what are all the properties and what are all the units for that? The next is about how we can measure the fluids. So that will be measured in terms of pressure. So the second chapter that represents pressure and its measurements of fluids. So this, the first module, properties of fluids and pressure and its measurements. That is the first module of fluid mechanics. Then the second module, it's about hydrostatics. So hydro is nothing but the water. What we have discussed now, the fluid statics. The fluid statics will come under the second modules. Means when the fluid is at rest condition, what are all the changes? Means how we can measure when the fluid is at rest. So if it is with respect to geometrical properties, how we can, when it is completely submerged or when it is off submerged, how we can find out the force or how we can measure the pressure in terms of fluid is at rest condition. That represents in the second module, that is about hydrostatics. Then what you are having the kinematics, that is the second chapter of second chapter of fluid mechanics. So that is about in the second module, first chapter that represents fluid statics and second chapter represents fluid kinematics. So we know that kinematics is nothing but fluid kinematics is a branch of fluid mechanics when the fluid is under motion without considering any kind of forces. Okay. So that will deals with second chapter of second module. Then third module it's about the fluid dynamics. So we know the fluid dynamics, it's a branch of fluid mechanics. Again in that we study the behavior of the fluids, the properties of the fluids when it is under motion with considering of forces. So if it is pressure force or if it is gravitational force. So we have to know how we can measure it when it is under moving condition. So now after completion of the third module, then the fourth module represents, it is about depth, velocity and discharge measurements. So till third module will just discuss the properties in terms of rest condition, in terms of moving condition. Next, what exactly to be measured? What exactly to be measured in terms of fluids? That is depth, velocity and discharge. Okay. So in that we'll get to know the types of flows, uniform flow, non-uniform flow, or it may be, the different types of classifications. What you are studying, rapidly varying flow, what you can say the another name of non-uniform flow, or it may be gradually varying flow. There will be of different classifications. So with respect to depth, with respect to the velocity, or you can say in terms of acceleration or in terms of discharge. So the fourth module that exactly represents, it's about after knowing the properties, how we can measure the depth, velocity, discharge with the equipments. So there are different equipments that you studied in the higher semester with a practical exposure, that is the fluid mechanics laboratory. So what exactly the orifice? What exactly the orifice meter? Or what is venturi meter? Or what is notches? So that all will be used to measure the velocity, discharge, or what I can say the discharge, another name is rate of flow, depth, that will be measured with the equipments, the orifice meter, venturi meter, or the orifice. There will be of different equipments, notches. So with the help of that, we'll do the measurements. Now here you will do the calculations part, how exactly we can measure. Then the fifth module represents, it is about flow through pipes. It is nothing but when the fluid which is moving in a closed conduit is nothing but the pipe. So when the fluid which is moving in a closed conduit, it is nothing but flow through a pipe. So we have to measure what will be the losses when it is the fluid is moving in a pipe, what are all the losses in terms of major loss, minor loss. So we have to identify when there will be of distribution network. So what exactly you are studying now the fluid mechanics? This is the basic subject. So next in further we will go with the advanced subjects, that is advanced hydraulics, and you will get next further is about hydraulic structures. Means if you want to design a dam or if you want to construct a hydraulic structures like canals or check dams, whatever, to know that in the third semester in the core department you will study about the basic foundation concepts, that is about the properties in terms of statics, kinematic, dynamics, then how we can measure the depth, discharge and velocity. The next is about if it is in a closed conduit, means if you want to supply water to a town, So we have to know what exactly the distribution network that has to be designed. So to know that, before that we should know what will be the losses when it has been through closed conduit. That is in the 5th module that you will study about flow through pipes. Okay, so this represents what I explained now, the 5 modules that is there in the subject of fluid mechanics. So in today's class, now what I have given the brief introduction about your syllabus and the classification of fluid mechanics. So next again I'll continue with the introduction about the first module, that is about properties of fluids. The first module and the first chapter, the introduction in the fluid mechanics, the properties. So what do you mean by properties? Means if it is any material, it is having some properties. If you are considering solid material which is having resisting property, what we can say the elastic properties. When it is coming to the fluid, what are all the properties which is coming under fluid? So I said you in the before introduction itself, fluid is nothing but it is not only liquid which consists of gases. So in fluid, we have to know what are all the properties and how it is going to work. So to differentiate in terms of oil and water, so differentiate in terms of forms of water, what we can say the rainfall, what we can say the droplets. So there will be of different forms, what we can say the mist, dew, there will be of different forms, but all which will be in terms of a fluid. That will be in terms of gaseous state or maybe in terms of liquid state. So now when it is coming to the properties, there are 2 categories. One is primary property, other one is secondary properties. So now in this session it's about primary property. Primary properties. So under primary properties, the first one, it's about mass density, that represents rho. Second one, weight density, that represents small letter w. Third one is specific gravity, that represents capital letter S, or sometimes it will be in terms of capital letter G. And the fourth one, specific volume. So these 4 are the primary properties of the fluid. So the first one, the mass density, sometimes it will be called as density itself. So what exactly the mass density? Mass density is nothing but that represents rho. Mass density will be m by v. It is nothing but mass density, it is the ratio of mass of the fluid by volume of the fluid. So if you want to know the definition for mass density it is the ratio of mass of the fluid by volume of the fluid, and the mass density unit is kg per meter cube. So mass of the fluid will be represented in terms of kg and volume of the fluid will be represented in terms of meter cube. So if you want to know what is mass density, it is the ratio of mass of the fluid by volume of the fluid, and that represents rho. So mass will be represented as capital letter M and volume will be represented as capital letter V. So rho is nothing but m by v, that is mass of the fluid by volume of the fluid. That will be represented in terms of SI unit is kg per meter cube. The next is weight density. So the weight density is small letter w. So small letter w again represents capital letter W by capital letter V. So that represents weight density is weight of the fluid by volume of the fluid. So now what you are having the primary properties. The first one is mass density, mass of the fluid by volume of the fluid, that represents kg per meter cube. Then weight density, the weight density is weight of the fluid by volume of the fluid. So that is small letter w is equal to capital letter W by capital letter V, weight of the fluid by volume of the fluid, and the SI unit is Newton per meter cube.